Today, I have Seth Shostak. He is an American astronomer and an author, and is currently the senior astronomer for the SETI Institute. Shostak hosts the SETI's weekly radio show, Big Picture Science, has played himself numerous times in TV and internet film dramas, and has acted in several science fiction films. He has a PhD in astronomy from Caltech and a degree in physics from Princeton University. Hi, Seth, and welcome to the show.
Well, I'm just fine, Evan.
Seth, I want to ask you straight off the bat here, what is SETI and what does it stand for?
Well, SETI is just an acronym. That's all it is. It's a generic acronym in the sense that there's no one organization that kind of owns it or anything like that. It's not like Coca-Cola. It just stands for the Search for Extraterrestrial Intelligence. And it's the effort made by scientists, I guess they've all been scientists, to try and find evidence that somebody's out there, somebody at least as clever as the residents of California, for example.
And Seth, what do you think about that movie Contact with Jodie Foster? Do you think that actually resembles anything of what it's really like to work for SETI? To support the show, go to evanweiss.com/NordVPN. Protect your browsing from criminals and surveillance. With NordVPN, all the data you send and receive online travels through an encrypted tunnel. This way, nobody can get their hands on your private information. Secure all your devices with Windows, Mac OS, Linux, Android, and iOS. Plus, you can protect up to 6 devices with a single NordVPN account. So go to evanweiss.com/NordVPN to get an unheard of 70% discount.
Well, of course it does, because it was based on the 1983 novel by Carl Sagan, and he knew something about SETI. He'd even done an experiment in SETI, and actually the film had a number of consultants, including myself, I should say, who could tell them some of the technical details of how SETI is done. So in terms of portraying what SETI scientists do, I suspected you could say it was the most accurate of all the films that have been made that involves SETI. On the other hand, the middle of the film, of course, had to do with Jodie Foster's taking a ride in a device that looked like something for Coney Island. That wasn't terribly accurate, accurate. I mean, it was rather speculative. The whole thing was speculative. But insofar as it talks about SETI, it's pretty good.
What do you think about the recent reports about signals being received from deep space onto Earth every 16 days? So apparently it repeats every 16 days. Do you think that's a signal from outer space, possibly from aliens?
Yeah, this is FRB, what is it, 0901. I've forgotten the name of the thing because that has a long name, which is basically the date on which this thing was found and the coordinates on the sky. It's the latest in a series of dozens of what are called FRBs, fast radio bursts. And this one, since it repeats, that means you know when to expect it next, and you can, corral a bunch of other telescopes, radio telescopes, and other kinds of instruments to really zero in on where this pulse is coming from. And it's coming from a galaxy, big face-on spiral galaxy, actually, the kind I used to study, about 500 million light years away. That's a long distance, and it's pretty nifty. I think it might be actually important in terms of figuring out what these things are.
Do you think these fast radio bursts are, in fact, from intelligent life, or do you think it could be interference from something that we're doing here on Earth?
Well, it's certainly not from Earth. I mean, it's 500 million light years away, and that's even farther than the distance to, Utica, New York. No matter where you are, it's a long distance. But it's undoubtedly not in my opinion, it has nothing to do with intelligent life because, several things. To begin with, we've found fast radio bursts, yes, in this galaxy over there, 500 million light years away, but we've also found fast radio bursts coming from that galaxy over there, 3 billion light years away, and another one from 1.3 billion light years away in another direction altogether. It's a little hard to understand how, if these were due to intelligence, how they corralled all these societies separated by billions of years and billions of light years to all doing the same sort of thing. That doesn't make any sense. So I think.
So what do you think it is?
Well, it's hard to say. Nobody knows for sure, but nobody knew what the pulsars were either, at least for about a year, until they were figured out by some clever theoreticians. I think the same thing is going to happen here. But the fact that it's every 16.35 days, right? And it has this repeating pattern. You get a fast burst, and then you get 4 days in which there's a lesser burst about every hour. That kind of behavior suggests that it's something in orbit. And probably, I mean, my guess, if I had to bet on anything, would be that this is a binary system. In other words, two stars, one of which is a black hole. It's collapsed into a black hole, and it's sucking stuff off the other one, producing all the radio static. And every time this thing orbits, you get to see the burst. But that's maybe a little naive. We still don't know what it is. But I think anybody who thinks that it's aliens is the victim of wishful thinking.
Does space sound like anything? In other words, if I were to be in space, can I hear something? Can I hear maybe like a distant buzzing sound of a solar system far away?
Well, space doesn't sound like anything really. I mean, space is largely empty when you think of outer space. It's not entirely empty. I mean, there are atoms and even molecules in space. And of course, they're virtual particles being created and destroyed all the time at a very small scale. I used to make a living studying radio waves from space produced by the hydrogen gas that's found between the stars. And it's not that it sounds like anything. It's just an emission line. In other words, it's just radio signal, a very narrow radio signal produced at a specific frequency. If you were to convert it into sound, I mean, you could do that, I suppose. It would just sound like a whistle, really, just a constant whistle tone.
So if I were to be in space, I wouldn't be able to hear anything. Is that what you're saying?
Well, not for very long. You'd be dead within about a minute. But
I mean, of course, yeah. If I could still be alive in some weird parallel universe, would I be able to hear something?
No. You need a medium to convey, sound. I mean, sound is kind of a terrestrial phenomenon, right? In space, nobody can hear you scream, as a famous movie said. Alien, and that's true because you can't hear anything. If you took off your helmet on the moon and tried to listen to the sound of space, you wouldn't hear anything.
Now, what do you think about the newly created Space Force? Do you think that's a really good idea, or do you think it's a little bit, I don't know, what do you think?
Well, that's actually has nothing to do really with astronomy. That has to do with defense. And there's no doubt that there's going to be increasing militarization of space, no matter what you think of that. And in the orbit and so forth. I mean, I think that, it's kind of inevitable that you're going to have more and more people working on space-related defense initiatives. So whether you need a separate Space Force or whether you want the Air Force to handle that or maybe the Navy or something, Starship Enterprise, after all, that's a political thing. But I know,
but from your perspective as an astronomer, do you think it's a good idea?
Well, I don't think it has much to do with astronomy. It's sort of like asking, your medical doctor, what do you think about the Space Force? How's that going to affect your job? Well, it's probably not going to affect his job. But the thing is that if you have, for example, weapons in low Earth orbit, what that means is now you can carry out an attack if you have, for example, energy-based weapons like lasers, high-powered lasers, things like that. You can take something out in a tiny fraction of a second. This isn't like ICBMs, which take at least 10 minutes to get from one country to another. So you have 10 minutes in which to do something to counter them. Here you will have a fraction of a second. You will not be able to counter them. So, militarization of space in the best of all worlds is something you wouldn't wish for, but I think it's kind of inevitable that it will happen.
Now, let me ask you this question. When do you think human beings will set foot on Mars? And why do you think it's taking so long?
Well, it's hard. I mean, it's just hard. People think it's easy because we went to the moon in 1969, but Mars is, what is it? It's about 120 times farther than the moon. And it takes about 6 or 7 months to get there, even with our fastest rockets. And once you get there, you have to survive for about 2 years because the window to come back is every 2 years. So that's a much more difficult thing than, spending 2 days going to the moon, making a landing, spending a couple of hours making photos or whatever, and then coming back in a couple of, 2 days. So that it's an entirely different order of magnitude. So it's difficult. But Elon Musk says he's going to do it by, 2025, 2023. something. I doubt that will happen. But on the other hand, he has a very, very good team of people building rockets, and the rockets have been pretty successful. So eventually, I think he can do it.
Look, I've always thought to myself, why can't we send robots with 3D printers and we can control them with VR interfaces or virtual reality interfaces? And that way they could start terraforming the planet. So when we get there, we're able to, put crops and build structures and actually have a foothold on the planet. I don't think any of these technologies are outside of the bounds of what we can do today. We could actually do that today. Why haven't we done that?
Well, you can do all of that. I mean, terraforming Mars is actually a very big project, and that might take hundreds of years, maybe thousands. That's a big project. I mean, how are you going to do it? What are you going to do to turn the atmosphere breathable? What are you going to do to make, to melt the water so that you can grow crops? I mean, all those things are, they don't violate physics. That's hard to do, but it's not impossible. And I really don't doubt that it will be done sometime. I don't expect to see much progress in terraforming Mars in the next, 20 years, but maybe in 100 years, you might want to consider doing it.
I mean, we already have the Mars rover, amongst other rover type systems up on Mars. Why can't we send them with 3D printers and start building structures?
You could send a 3D printer to Mars tomorrow if you wanted to send one, and you could build keychains. But how does that help you?
I mean, it's the idea that if we send off these systems, these AI systems with VR interfaces and 3D printers, they can help us in a way build a beachhead so we can come later on. I don't think that's anything that we can't do right now. The question is, why aren't we doing it?
Well, I don't know what you mean by that, because in order to subsist on Mars, right, you need to be able to breathe, you need food, you need fuel to get back, you need all those things. And there's your little 3D printer sitting on a desk, but what does it do? Mars has, what's the gravity on Mars? I think it's like 38% of what it is on the Earth, something like that, about a third. So that means you do need a rocket to get things off of Mars. The moon's a little easier because it has less gravity and it's a lot closer. You could get things off of Mars. What do you think would be worth bringing back from Mars other than humans?
Now, this is the best question for a high-level SETI astronomer: is have aliens visited Earth? And if not, why not? Where are they? Why are they hiding? What do you think is the theory behind the elusiveness of aliens on Earth?
Well, I'm pretty sure that they must exist. There's just too much space for that not to be true. As far as whether they visited the Earth, I've never seen any evidence for that. That seems very convincing. If they might have visited during the time of the dinosaurs, and there wouldn't be much evidence. I mean, that's you can't really rule that out. I mean, maybe they came a billion years ago and bottled up some microbes and took them back. I mean, you simply wouldn't know. But in modern times, if you say, well, did the aliens, visit the Maya or something like that? A lot of people like that idea. Or did they crash?
The ancient aliens theory.
Yeah, ancient aliens. Yeah, they're not very ancient when you think about it, because they're talking about structures that have all been built in the past, at most 5,000 years. Well, that's all today. That isn't any earlier than today from a geological perspective. I don't think that any of that evidence is terribly good. There are plenty of people who do, but, I'm not one of them.
Now, if SETI were to find and identify a planet with intelligent life, should we make contact with them, or is it better not to?
Well, I don't know that it'd be a bad idea. I mean, if they want to know about us, they could, build a big antenna and pick up our television, and then they would know a lot about us. And maybe some of them have that kind of capability already. But in terms of conversation with aliens, look, the nearest aliens might be 1,000 light years away. Let's say they're only 100 light years away. That would be very close, but let's say. If they're 100 light years away, you can say, well, let's get in touch with them. So, you send a message. Hi, we're Earthlings, and this is our message to you. We just want to say roses are red and violets are blue, whatever. And it takes 100 years to get there, and then they respond. That's another 100 years. So conversation is going to be very, very slow. That isn't to say it isn't worth doing or trying, but it means that you're not going to have a whole lot of conversation within a single human lifetime. So there's that.
I mean, so SETI really is an organization. I mean, like in the movie, like Contact, it's like there's like a huge satellite, kind of like a huge dish that's I think it's in Puerto Rico or something. It's a huge dish that looks like a satellite. Now, SETI is not that. SETI is more of the organization itself, right?
Well, yeah, SETI is the discipline. It isn't even an organization.
So let me ask you this: why do you think, when the discipline of SETI and all its technology and all its brain trust, when you guys look out there into space, why is it so quiet in terms of intelligent life, in terms of intelligent life activity? Why?
Well, we don't really know that it's quiet, actually. We haven't picked up any signal, but that just means that none of the signals is at the right frequency to have been picked up by us and at the right signal strength. That's a really important thing. And also arriving at the right time. All those are, I could go out into, I don't know, the Mojave Desert, right? I don't hear anything, right? I don't hear any people, but that doesn't mean there aren't any people on the planet. It's just that my experiment isn't a very good one. I mean, it could be that the only reason we haven't picked up anything from ET is that we haven't looked at very many star systems, which is true. We've only looked at, maybe 1,000. That's a rather small number compared to the number of planets in the right now. But it's also the case that we have limited sensitivity, and it may be that the cosmos, or at least the Milky Way, is flooded with signals, but they're all below our level of detectability, right? I mean, I can go out and, if I'm standing near an AM radio station, I might be able to hear the music that they're broadcasting on my teeth, right? Because if you have a filling, that's a kind of a rectifier. It's kind of a detector, a radio detector. And there are people who can hear radio stations in their teeth. It doesn't sound like, yes, but it doesn't sound like a lot of fun. But, maybe they can. On the other hand, I'm not going to, I had fillings and I don't hear any radio stations. It doesn't mean there aren't any radio stations. It just means that my detection apparatus, at least insofar as the detection apparatus isn't the equipment that's in my mouth, isn't good enough to pick them up. Whereas if I built some sort of amplifying system, I could pick them up. So that may be the case with SETI. We're trying to pick up ET with our teeth, whereas in fact we need better receivers. The idea that life came to us from another planetary system somewhere else in the galaxy, and life got kicked off some planet somewhere around a different star, and inside a rock, and got carried to Earth and infected the Earth, and we're all descendants from, some Klingon rock. That could be, but people who, astrobiologists who study this sort of thing will say, it's one thing to send life from Mars to the Earth in a rock, that you could do, but to send it from another star system to Earth in a rock, that distance is so much greater that the rock would, be subject to all this bombardment by high energy radiation in space, the desiccation. There's no liquid in the rock, because there's no pressure in space. Really nothing could survive.
Now, if you're an amateur and you want to get into astronomy, do you have to purchase an expensive telescope to do that?
If they want to enjoy astronomy, I think people can enjoy astronomy without buying an expensive telescope, just as, you could enjoy great novelists without having to buy a reader, an electronic reader. You can buy a book. You can enjoy astronomy with a pair of binoculars or just your eyes. I mean, astronomy up until the 1600s, astronomy was all done by naked eye vision. That's all there was. And there were plenty of people who enjoyed it. So you don't need an expensive telescope. And I would say if it's the first instrument you're going to buy, I wouldn't buy an expensive telescope because it's so complicated and difficult to set up because they're big and they're heavy. It'd be better to start with something small. Even binoculars, there are binoculars that are specially designed for astronomy. They have really big objective lenses. They're a little more expensive, but you can see quite a bit. You can see nebulae and things like that. And it's easy enough to take them outside.
Okay. Now, where does space begin and where does space end?
Officially 65 miles up. 100 kilometers is sort of the official definition of space. Of course, that's pretty arbitrary. That was set up by, that was sort of declared by people in the space community. 100 kilometers up which is roughly 61 miles.
And here's a question that I've always wondered, and I've always wanted to ask someone like yourself. How was the moon formed?
Well, the current theories tend to favor the idea that the moon was the result of what's called the big whack. I think it was called the big whack, where you have something about the size of Mars that slammed into the Earth about 4 billion years ago, and knocked a whole bunch of stuff off the Earth and kind of pulverized the rock that hit the Earth, and that stuff formed a ring around the Earth, and much like Saturn's rings, but that material eventually coalesced into something we call the Moon. So it was the product of a collision. It's noteworthy that you might say, well, is that the way all the moons of the solar system were formed? And the answer is no. But the Earth has a very big moon for an inner solar system planet. You can look at Mercury, it doesn't have any moons. You can look at Venus, it doesn't have any moons. You can look at Mars, it has 2 tiny moons you could walk around in the course of an evening. So Earth is very special in having this big moon. So something special did happen to the Earth, and it's most likely this big whack.
Okay, so another question related to the moon is why, when the moon gets closer to the horizon, it looks larger? Is it like an optical illusion?
Well, that's just your brain. The moon actually isn't any larger closer to the horizon, obviously, and that's just a physiological thing, right? I mean, if you don't believe that, you can make yourself a little device with some cardboard and a mirror, a shaving mirror or something, and move the moon up to the zenith, even though it's near the horizon, and you'll see it doesn't look any bigger. It's always the same size.
Okay. What are comets, and where do they come from?
Well, comets are just, essentially rocks left over from the birth of the solar system. And so they came from the same place that all the planets came from. I mean, there was what's called a primordial nebula or nebula, shouldn't use the plural, that formed the sun and the planets and lots of small things too. In fact, the planets were probably formed bottom up, where they started out as small objects and then collided with one another and eventually pulled one another with their own gravity, making bigger things. And the comets were formed mostly in the outer solar system, where there was a lot of water ice. So they're covered in ice. The inner solar system, there was probably a lot of water ice too, but the sun, the nascent sun, the baby sun, was hot enough to, evaporate all that water. So objects in the inner solar system tend to be kind of more ice-free, like asteroids, right? I mean, the asteroid belt, they do actually have a fair amount of water on their inside, but they don't have ice so much on the outside, whereas comets, which are farther away, do.
Okay. Now, here goes another question that might be just a very curious guy. What can I say? Now, if tides in the ocean are affected by the moon's gravity, why are lakes not affected by the moon's gravity? In other words, why do lakes not have tides?
Well, I think they do, but the amount of water is considerably less, right? I mean, tides are just the difference in the pull of the moon, right, when it's in certain positions on the sky. I mean, it's just, the moon is pulling on the Earth, and it's pulling on the near side of the Earth a little more than it's pulling on the far side of the Earth, right? It's because it's closer. So the far side of the Earth gets sort of the ocean, the Earth gets pulled away from the ocean on the far side, and the ocean gets pulled closer to the moon on the near side. So you get tides on both sides of the Earth.
Now, we all know that larger objects with greater mass pull smaller objects towards itself with a gravitational pull. What keeps them from colliding?
You're pulling on the bookshelves in your apartment or house, right? Because you both have the pull of gravity. But those books don't come flying into your face because there are other forces that are keeping it from doing that. And the pull of gravity is the weakest of all the forces. So it's not very strong. It takes something the size of the Earth to pull on you with a force that, translate to 150 pounds or whatever it is to keep you in your chair. But it's a very weak force. And if it weren't a weak force, then things would be glomming onto you all the time.
Okay, but what keeps the moon from colliding with Earth, in other words?
Well, I mean, Newton worked that out 400 years ago, right? That the moon is falling around the Earth in the same way that satellites are doing. So it orbits the Earth because, it if it had been formed in such a way that it could follow a straight line back down to the Earth, then that would have happened. But it wasn't. It had a little bit of orbital angular momentum, so it starts spinning around the Earth, and it just keeps falling around the Earth. I mean, Newton's idea that you take a cannon and you fire a cannonball and it goes 50 yards down down the landscape and it falls to the ground. But, you get a bigger cannon and it goes 100 yards, and then a bigger cannon goes 1,000 yards, and then 10,000 and 100,000 yards. At that point, it's beginning to, when it falls down to the Earth, it falls around the Earth because the Earth is dropped away because it's a sphere.
All right, Seth, here comes another hardball question. And I know you're a very smart guy, so I know you'll be able to answer this. But why is it that we can't travel while not moving? In other words, let's imagine a planet Earth and a helicopter that's on a launching pad. Imagine the helicopter rises vertically and lets the Earth underneath it rotate. And when it reaches its destination, it lands again. What is the force that keeps the planet, while it's rotating, not stationary? Like, what moves it with the Earth's rotation? What is that phenomenon? What is that mechanism? What is that what tethers the helicopter and the Earth while it rotates?
Because the helicopter was on the Earth when it started, so it was rotating with the Earth, right? I mean, if it could fly in the other direction at the speed at which the Earth is rotating, which, depending on where you are, is, near the equator, it's like 1,000 miles an hour. If you've got a helicopter that can go 1,000 miles an hour and goes the opposite direction in which the Earth is rotating, then, it's not rotating with the Earth anymore, and, the landscapes will pass below you. But you might look at that a different way and say, well, that's because the helicopter is going 1,000 miles per hour in the west, toward the west.
All right, Seth, this question might aggravate you a little bit, and it is, why do you think there's still people who believe in the flat Earth theory?
Well, I think they're deluded. I mean, come on. That's, if you still believe that, then, obviously you don't pay attention. You don't pay attention to the most obvious things. You don't pay attention to obvious things like when you go to the beach and watch ships disappear over the horizon and stuff like that. Or you don't believe that the photos made by astronauts on the moon showing around Earth, you figure those were all faked or something like that. I mean,
I understand, but why do you think people still believe it? Why? I mean, it's really popular on YouTube now, and there's people who, they have conventions, flat Earth conventions, where thousands of people attend. Why do you think? Do you think there needs to be more education? Do you think people should learn more about science? What's your opinion?
Well, nobody could be against science education, but I think that there are some people who just prefer to have a contrary point of view because it's somewhat powerful for them to think that they understand something that those pointy-headed guys down at the local university don't understand. But in the case of the shape of the Earth, there are plenty of people who've made trips around the world who understand that it's round. Magellan certainly did, and that was, 1530?
All right, Seth, is there anything you want to talk about that I might have not brought up?
Well, we didn't talk too much about the search for life elsewhere, but we don't really have to. I think that...
Actually, I do want to talk about that. Tell me more about it.
Well, all I would say is that here at the SETI Institute, we have about 100 PhD scientists, and most of them are working on trying to find life in the solar system, mostly Mars, but there are other places than Mars where there might be life nearby. 2 of the moons of Saturn, 3 of the moons of Jupiter, maybe in the atmosphere of Venus, and of course Mars. These are all places where there could be life within a rocket ride, not very far from Earth. So that would be interesting to find. You might say, yeah, but that's going to be pond scum, and it is. But on the other hand, if you found pond scum somewhere nearby, you would say, okay, this is kind of the proof you need that life is very common in the universe. Because if we found 2 examples of it, then it must be all over the place. So it's like saying, oh, you know what, termites are really, really exceptional. I suppose I'm the only house that has termites. And then you find that a neighbor 2 houses over also has termites, and you decide maybe termites aren't so exceptional. So it would be the same if we were to find that. So that's what they work on. And then there's also the small group here, of which I am part, who is looking for intelligent life. And that's...
So are there any contingency plans in the event that we do make contact with alien life?
Well, you would know about it. It would be a big story. And of course, every telescope in the world would look at it. And we try to find out as much information as we could. How far away are they? Can you find any planets in that direction? That kind of stuff. It would be a very big discovery. And I think it would certainly change our view of ourselves, because we realize, oh, well, we're just another duck in the row. And that might be a good thing to hear. But, it isn't that you wouldn't have to go to work tomorrow.
And at that point, will the government take over the SETI project, or you guys work with them, you guys interface with them, or what's the structure there in the event that we do make contact with aliens?
Well, I'm not sure how the government could take over. A lot of people, tell me that. They say, the government would shut you guys down. There hasn't been any interest by the government in what we do since 1993, to be honest. But, we've had some false alarms, and the government shows no interest whatsoever. So, and not only that, but the government couldn't really shut it down. I mean, this is just, if there's evidence for aliens up in the sky, it's up in the sky, and anybody with a telescope can, point it at the sky. I mean, radio telescopes around the world. So it's not the kind of thing that the government could shut down.
Yeah, it seems like in that event, you guys would be working more closely with the government.
Well, they might fund things. That would be good.
So I know with all these years of looking for intelligent life out there, I know at some point you must have contemplated or thought to yourself, what do these beings, if we were to find them, look like? What do you think they would look like?
I suspect, given our own technological trajectory, that the most of the intelligence in the universe is machine intelligence anyhow. So the idea that they would be, biological is probably very naive. By the mid-century here, we'll have, machines that can do anything cognitively that humans can do. That's the prediction anyhow. And maybe it'll take another 50 years or another 100 years, it really doesn't matter. All those times are the same length of time. So it will, if we're doing it, you can assume that many of the aliens who've had a couple of extra billion years to do stuff will have done it already. So I think that the preponderance of the intelligence in the universe is probably machine intelligence. Yeah.
Well, in a way, that means that biological systems like us will be obsolete. What do you think about that?
Well, it doesn't mean that we would disappear necessarily. I mean, right? The fish gave rise to land mammals eventually, right? But the fish are still there. So I don't know. I mean, they're different fish, but I don't mean that I don't mean to suggest that once we have thinking machines that can outthink all humans, that suddenly humans will be obliterated somehow. I mean, it's possible, I suppose, but it isn't obvious to me that that's an inevitable consequence of developing machine intelligence.
Seth Shostak, thank you for joining me on the show. Talk to you later. Bye.
Thank you for listening to The Evan Weiss Show. Head over to iTunes to listen to previous shows. Questions? Email us at e@evanweiss.com.